This is exercise 2.4, question number 8. Without actual division, prove that x to the power 4 plus 2x cubed minus 2x squared plus 2x minus 3 is exactly divisible by x squared plus 2x minus 3. Now before we prove this, you need to understand what is factor theorem, because this is the theorem that we're going to use here. Factor theorem says x minus a is a factor of px if pa is equal to 0. This is a very simple concept. What it says here is, if a polynomial px is divided by x minus a and the remainder is 0, then x minus a is a factor of px. Now to understand this, let us consider 3. Okay, 3 is a factor of 9 because 9 is exactly divisible by 3. That means the remainder is 0. 3 3s are 9. Or say 6 is a factor of 30 because 30 is exactly divisible by 6. Here in this cases, both the cases, remainder is 0 here. Remainder is 0. So when we divide a number by another number and if the remainder is 0, then the second number is said to be a factor of the first number. And another very important thing that we're going to use here is, let's take this 6 and 30. Now 6 is a factor of 30. That means 30 is exactly divisible by 6. Now if we break 6 into its factors like this, again 2 into 2 and 3, then here we will find that 30 is again exactly divisible by 2 also, by 3 also. So when, in other words, we can say if 30 is exactly divisible by 2 and 3, then 2 into 3 is a number such that it is also a factor of this 30. Now this is the concept, this is the idea that we're going to use here in this question. Now here let's say px is equal to x to the power 4 plus 2x cubed minus 2x squared plus 2x minus 3. Now here the divisor is x squared plus 2x minus 3. So first let's find the value of x for this, zeros of this divisor. So x squared plus 2x minus 3 is equal to 0. Now what we're going to do is we're going to factorize this using splitting the middle term method. So now we have to find two numbers such that when you multiply you should get 3, and this sign when you subtract you should get 2, this middle term, coefficient of x. Now this is nothing but 3 1s are 3, 3 minus 1 is 2. So I'm going to write like this, x squared plus 3 minus 1 x minus 3 is equal to 0. Now this is x squared plus 3x minus x minus 3 is equal to 0. Now we're going to take common. Remember, taking common is nothing but dividing both the terms by a common term, a common number. So here in this case x squared plus 3x these two terms we can divide both of them by x. So that means we can take x common. So we're going to take x common. So x squared divided by x squared divided by x, which is nothing but x, or you can think in this way, x, you get here x plus again this term divided by this x, 3x divided by x cut, you will get 3 here, and in these two terms you can take 1 common. So x divided by 1 is x minus minus plus 3 divided by 1 is 3. This is equal to 0. Now again we have here x plus 3, here x plus 3, so we can take x plus 3 common again, and then here in the first term we will get x cancel out, and in the second term we have minus here. In the second term this 3 and this 3 cancel out, so you get here 1. So this is equal to 0. Therefore either x plus 3 is equal to 0 or x minus 1 is equal to 0. If two numbers are such that their product is equal to 0, that means either a is equal to 0 or b is equal to 0. So this is what we are using, this property. So this into this is equal to 0, that means either this should be equal to 0 or this should be equal to 0. Now we transpose 3 to the right hand side, so plus become minus, and here in this case minus become plus. So these are the two values of x, zeros of x. Now we're going to substitute these two values one by one in this given polynomial, and if we get 0, then our work is done. And if we are not getting 0, that means this x squared plus 2x minus 3 is not a factor of this given polynomial. So what we're going to see is, we're going to see whether we're going to get 0 or not. Now let's do with this minus 3. So p minus 3 is equal to minus 3 to the power 4, minus 3 to the power 4 plus 2 into minus 3 cube minus 2 into minus 2 square, minus 3 square, sorry, plus 2 into minus 3 minus 3. Now this is minus 3 to the power 4. This is minus 3 into minus 3 into minus 3 into minus 3. Here the power is even number, so this is going to be plus. You can also see like this, minus minus plus, plus minus 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 plus. Again 3 3s are 9, 3 3s are 9, 9 9s are 81. So this is 81. Similarly here minus 3 cube. Now we check the power. The power is odd number, so the answer is going to be minus. So 3 cube is 3 3 are 9, 9 3s are 27, 27 2s are 54. So plus minus is minus. So this is going to be minus. This is going to be minus. So 27 2s are 54. And then again here the power is even number, so we get plus here. 3 3s are 9, 9 2s are 18, plus minus minus 2 3s are 6, minus 3. Now this is 81. Now all this negative number we're going to add. So 6 plus 3, 9, 18, 27, 81. So 81 minus 81 is 0. Okay, so we got 0 by substituting minus 3. Again, we're going to check with 1. Now let's say P1 is equal to 1 to the power 4 plus 2 into 1 cube minus 2 into 1 square plus 2 into 1 minus 3. This is equal to 1 to the power 4 is 1, 1 cube is 1, 1 into 2 is 2, minus 1 square is 1, 1 into 2 is 2, plus 2 into 1 is 2, minus 3. Now this is 1 plus 2, 1 plus 2 plus 2 is 5, minus 2 minus 3 is minus 5. Again here also we are getting 0, which means that the remainder in both the cases are 0. This shows that this x square plus 2x minus 3 is a factor of this given polynomial. So we have already proved here. Hence x square plus 2x minus 3 is a factor of the given polynomial px, that is, the given polynomial is exactly divisible by x square plus 2x minus 3. Hence proof.